Hello, class. So this is our final lecture, okay? And for some reason, it has to be section 12.6, okay? And it should be a short one, actually, because I don't even really want to teach you all of 12.6. You just really need to know one single thing. So I'm going to call this section Pascal's triangle, okay? And it revolves around the issue that some of you have been making, maybe. So remember this thing, right? The mistake I told you to never make is just to square both sides, right? Because technically what you're supposed to do is you're supposed to FOIL, right? And then if you memorize the formula, you know it's this, okay? Now, that's like a little bit annoying, but fine. But what if I asked you like to do it more, right? So this, right, is A plus B 3 times. And then, right, you know what this is. That's a squared plus 2ab plus b squared. So now you'd have to like FOIL all of this, right? And you get like a cubed plus 2a squared b plus b squared a plus b squared a again plus 2ab squared plus b cubed, which if you add all the like terms up gets you this thing. Okay. And then let me just, point out that if you think you see a pattern, you are right. Okay, there is a pattern happening. In fact, the pattern has to deal with what I'm going to call, or what we call Pascal's triangle. So Pascal's triangle, you might have been able to make it before. Okay, you need to know how to. It starts with the 1, and then you put 2 1s, and then you put 1, and then you add these 2 and put 1s. And then you kind of just keep going. Okay, and it goes on forever. The thing I want you to notice is look at this, right? 1, 2, 1, and then 1, 3, 3, 1. Okay, and if I were to tell you what's this thing, x plus y to the 4th, it's going to be x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. Okay? So Pascal's triangle is actually what tells us what these numbers should be. Okay? So you don't actually have to FOIL it out, right? Because this would be really, really annoying to FOIL because you'd have to do like 6 of these, right? Okay, so Pascal's triangle is really just like a tool that we use to figure out, how to expand binomials. Okay, so I wrote the 5th layer, so I might as well, right? What is a plus b to the 5th? So how it works is just start with a, and it goes a to the 5th, a to the 4th, a cubed. It just keeps going down. Okay, and then the b's do the reverse order. So technically this is b0, b1, b2, b3, b4, b5, because technically this is a0, okay? And then you put the Pascal's numbers in between. So plus 5, plus 10, plus 10, plus 5, just kidding. And then this is plus 1, because this is a 1 too. Okay? And that's honestly how you do it. There should be like no math required, really. It's just patterns, okay? the A's go down by 1, the B's go up by 1, and then the numbers are the Pascal triangle numbers for that row. Okay. Now, if it's not letters, then that's when it gets a little more complicated. So like x plus 2 cubed. Okay. Well, then you still do the Pascal's triangle thing. So x squared, x1, x0. But then, right, this is 2 to the 0, 2, 1, 2 squared, 2 cubed. And then put the Pascal's numbers in. So 1 plus 3 plus 3 plus 1. But since this is a number, these are numbers, and you actually have to like do some calculation, right? So if you simplify this, this is going to be x cubed. This is going to be 2 times 3. So I get a 6 here. This is going to be 4, right? Because 2 squared times 3. That's 12. And then this is going to be 8. Because 2 cubed is 8. And x to the 0 is 1. Okay, so there you go. This is actually the answer. Okay. So when you have numbers involved, that's when you could, get to mistakes because you have to calculate things. Okay. So another thing I want to show is what happens when you have a minus sign. Okay. So honestly, nothing special happens. It's just, you do what you normally do. Okay, so this is 2 to the 0, 2, 1, 2, 2, 2, 3, 2, 4, and then put the Pascal's numbers in. So 1 plus 4 plus 6 plus 4 plus 1. Okay, actually, I made the mistake. All right, the mistake is that minus 2 is actually just plus negative 2. Okay, that's the mistake I made. So what you should have done, and what I should have done, okay, so x minus 2 to the 4, okay, is this 2 should actually be negative 2, okay. All right, so it should be negative 2, which means something weird happens, right? So this is going to be x to the 4th. This is actually negative 2, so that means this is going to be negative 8 cubed. This negative 2 squared is actually 4, okay? So that means you get 4 times 6, positive 24 x squared. But then negative 2 cubed is negative 8. And then negative 8 times 4 is going to get you negative 32 x. And then lastly, 2 to the 4th power, that's just 16. Okay, so what happens when you get the minus signs is you notice the sign alternates. Okay, it goes plus, minus, plus, minus, plus, minus, because of the powers, right? For all of the even powers, the minuses is going to cancel, but for the odd powers, the minuses stays around. Okay? All right, and then, honestly, this is it. This is pretty much the whole chapter. I just need to show you this one thing. Okay, so here's like a hard example. Okay, find this, expand this. Okay, so 2x to the 5th plus, I'm gonna just put the Pascal's numbers right away, and do it like, a little bit differently. But, this is the same. Do not worry. 10 to 2. This goes up by 1 plus 5. 4 plus negative 3 to the 5th. Okay? So this is going to equal to 32x to the 5th plus, and this is going to be a little nasty, so 16 times negative 3, so this is going to be negative 240 x to the fourth plus, okay, and then this is going to be 9 times 8 times 10, so 720 x cubed minus, this is going to be 27 times 4, then a negative 10, so this is going to be negative 280. And then this last one, so 3 to the fourth power. Do we even know what that is? It's 81, okay. 81 times 10, that's this. And then the last one, negative 3 to the fifth, that's negative, so it's going to be negative 243. And ta-da, there's the answer. Okay. All right, so that's technically the end of the section. If all you learn is this, that is fine. This is the question that'll show up on the final. It's just going to be expand something. Okay. Now, for completeness' sake, okay, because I'm supposed to be teaching you pre-calc, I need to teach you the binomial theorem, okay? Okay, so the binomial theorem is the same thing. So a plus b to the n. So it's the Pascal's triangle, like this order thing, okay? But instead of using Pascal's triangle, we're gonna use something else. I'm just gonna skip to the last one, so plus b to the n, okay? We're gonna use, okay, what is it, n0 and 1 plus n2, and then this last one is n to the n. Okay, so this weird parenthesis thingy that I just made here, okay, that's called a binomial coefficient. Okay, and the beginning of chapter 12 is really all about this and something called permutations, commutations, factorials, all that stuff. So I'm gonna just kind of crash course you through the rest of chapter 12 really quick. Basically, whenever you see this thing, it's this formula. Okay, so n choose k, that's how we say this, is going to be n factorial over k factorial n minus k factorial. Okay, so then the question is, what's a factorial, right? So n factorial is going to be 1 times 2 times 3 times 4 times all the way up to n. Okay, so 1 factorial is 1, 2 factorial is 2, 3 factorial is 1 times 2 times 3, which is 6. 4 factorial is 1 times 2 times 3 times 4, okay, which is 24, and then it keeps going. Okay, they get big kind of fast. 5 factorial is 120. Okay, so that means you should be able to calculate the binomial coefficients now. So for example, 9 choose 4, okay, is 9 factorial over 4 factorial, 9 minus 4 factorial, okay, which is 9 factorial over 4 factorial, 5 factorial. Okay, and what you want to not do is just punch this into a calculator. Well, if your calculator has a binomial button, then go ahead and do that. But I meant, like, factorials get really big really fast. So if you, for example, like if you tried to put 25 factorial in your calculator, it would probably error out because it's too big. Okay, so you need to be a little clever. Okay, so remember that 9 factorial is just this, right? It's all of these numbers multiplied together. Okay, and 4 factorial is 3 times 2 times 1, but we don't care about the 1 really. And then 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, and since there's no pluses anywhere, you can just cancel. Okay, a lot of things. So I'm going to cancel this 3 with the 6. Well, I'm going to cancel the 3 and the 2 with the 6 here. I'm going to cancel the 8 with the 4 and get a 2 left over. And look, I literally canceled like everything. The only thing that's left is 9 times 7 times 2. Which that you can do in your head, right? What is that? That is 60. Wait, okay. How do I want to do this? That is going to be 63 times 2. Okay. 63 times 2. It's 126. Okay. And there you go, binomial coefficients. Okay. So if you wanted to use the binomial theorem instead of, okay, Pascal's triangle, you could. Okay. But I'm not going to force you to do that since you kind of need to know a lot about this factorial stuff, which is the rest of chapter 12, which we did not cover. Okay. But honestly, that's pretty much it for this section. Okay. Just be able to expand something. Okay. If I ask you, you know, like something like this on the final, just be able to show your work and calculate it out. Okay. But that's it. Good luck on your final. All right. Good luck.